All right, so this is going to be a video on some factoring shortcuts and some special forms of factoring. Factoring is going to become really, well, it already was important, but it's going to be really important when we get to polynomials, because it'll make your life so much easier if you are familiar with how to factor in some shortcuts and how to do it. So you should be watching this video after you have completed the other factoring stations so that you have the basic factoring down. And this is going to be a video on 4 different techniques for factoring, as well as we'll do some, there will be another video on this, but the techniques that we're going to look at are the perfect square factorings, which actually we've been doing for a long time, so it's not really that much of a shortcut. It's basically what we're doing with completing the square. We're going to look at difference of squares, which is also another normal factoring thing that you guys probably have seen and noticed before. And then we're going to look at 2 things that might be new, which are the sum of cubes and the difference of cubes. So we're going to start off with perfect squares. So perfect squares have the form of a squared plus 2ab plus b squared. And that might not make a whole lot of sense to you, but here's an example of this one. This is a positive perfect square. I have x squared plus 6x plus 9. From my formula, and basically from what you know, you can just use the idea that I need 2 numbers that multiply to 9 and add to 6 to solve this one without too much extra thinking. You should just be able to say that this one is x plus 3 squared, okay? It's a perfect square, so there's only going to be one of these and not 2 of them side by side because it's a square. The same logic goes for if this is a negative right here, x squared minus 14x plus 49, looking for 2 numbers that multiply to 49 and add to negative 14. That just so happens to be 2 negative 7s. So I'm going to do x minus 7 squared. Okay? Those are perfect squares. You guys have done that before. Just a quick overview. Difference of squares, you guys might not know by name, but I'm pretty sure you guys have done it before too. That tells me if I have 1 squared, a squared, minus another squared, b squared, then my factoring is going to be a plus b, a minus b. An example of this, normally for you guys, which I think this is a little bit more advanced, but a normal example would be like x squared minus 36. I'll say x squared minus 36. That means that I have a positive 6 and a negative 6 as my factors. So I would get x plus 6, x minus 6. For our example problem over here, this is a little bit more complicated. I'm going to look. I have a perfect square here and a perfect square here, but it's not just x squared. My perfect square, I need to factor that out, so it's going to actually be 4x squared. 4x squared gives me the 16x squared. Or sorry, 4x squared gives me 16x squared. This 36 is just a 6 squared. So if I do that, I look at my a and b, so 4x is a, 6 is b, so that means that my factorization is going to be 4x plus 6, 4x minus 6. Okay? So that is just it's a little bit of a step up. They both work, so that is another easy way for you to factor those really quickly. Now, we're getting into cubes here. So we have been working with polynomials up to degree 2 up to this point. And when we get to polynomials, we'll probably be working with polynomials from degrees 3, 4, 5, and 6, most likely, will be our polynomial degree. So this is a polynomial of degree 3, and it's saying that if you have a situation where you have a number cubed, or an expression cubed, plus another expression cubed, it is going to factor into this big guy, a plus b times a squared minus ab plus b squared. You're just going to have to write it down. You might not even necessarily memorize this formula, but you should know that if you encounter a situation like this, that there's a formula for you to factor. Okay, so even if you don't memorize that, which even I don't really have it memorized, you will be able to think, oh, I know this is a sum of cubes, I should look up this formula. Okay, so this x cubed plus 64, okay, you might not recognize the cubes as fast as you do your squares, but I can see that I have an x cubed, so x is being cubed here. And I have to think, what number cubed would give me this 64? if you think about it, 4 times 4 is 16. 16 times 4 is 64, so that means that I am cubing a 4 over here. So my A is x, my B is 4, so that means that my factorization is going to be x plus 4. And I have a squared, so x squared minus ab, so minus 4x, plus b squared, so b squared is 4 squared plus 16, okay? So that would be my factorization of here. Technically, you could factor that in. No, you cannot factor this particular one out any more than it is right now. So this is the factorization of a sum of cubes, although you could solve this one. Okay. Last one is the difference of cube. That is a term cubed minus another term cubed, and it looks very similar, just a little bit opposite. The only difference actually is that these two signs right here flip. They just switch places, okay? So you have a minus b times a squared plus ab plus b squared, okay? So again, you want to be looking out for the situation where you might use this cubed. You can see a cube here. 27 is a cube, so just to run down our cubed numbers, go like this: 1, 8, 27, 64, 125, so on. So these are your first ones. I won't give you really big ones because that wouldn't be very nice. So I can look here, I'm thinking, what is this cubed? I can see that 27, goes along with 1, 2, 3, 4, 5. So 27 is 3 cubed and x cubed together, so this is 3x, and that 3x is being cubed minus 1 cubed, is just literally 1 cubed, okay? So we have 3x is my a, 1 is my b, so that means that my factorization is going to be 3x minus 1 times 9x squared plus 3x plus 1. Okay, so this is another factorization. This one, again, I don't think that you can factor any further, but these are the special forms and shortcuts for factoring some of the more difficult factorizations, expressions that you need to do. So watch this video, do some of the practice problems on the next page, and then you can watch a video on use substitution, which will come later.